Colleagues, I will stick to my promise of the coffee break at 11:15. I will not permit 10 minutes discussion, but maybe 6. Margaret, go ahead.
Okay, thank you. So, this, you'd be surprised, is a purely technical question, but a lot of your foundations of trust relied upon the color coding, which is presumably why you gave it us at the beginning, and you limited it to, or its limits were, 20. Now, my question is, 20 is a small number for the number of occurrences that can happen on roads. I'm wondering how far you can make finer chromatic distinctions which would be necessary to avoid different kinds of accidents. Last point, just 3 examples of my most famous accidents in a car. Australia and the kangaroo, very different shape, from Scotland and a deer, and the French Alps and a wild boar, sanglier. Now, how would that be coped with? Can it be coped with?
Let's listen to a few other comments. Please take note. Greg?
Yeah, thanks very much. And I was struck by your comment that we need to make some...
Microphone, please.
Oh, I thought it was on.
It is on.
Oh.
You must speak.
Oh, speak into it. Yeah, that we need to make some... Societally, we need to decide what sort of risk we want to assume with respect to driverless cars. I think it's important that that discussion be a comparative one to the risks we assume with human drivers. And I've been struck at how context, how the relationship between drivers and pedestrians differs dramatically from context to context. And over time, like I didn't have a car for many years, now I have a car in Oslo, and I'm shocked at how safe pedestrians think they are. They step into the pedestrian lanes without even checking to see whether the driver sees them. And often I'm surprised that someone's suddenly there, you know. I was in Tehran. It's very frightening crossing the pedestrian lanes because the cars just keep coming and you're expected to somehow, they weave in with the pedestrians. So driverless cars are going to have to be adjusted to these different contexts, and it keeps changing. So.
Please take these 2 concerned drivers and pedestrians questions. Christoph?
Yeah. Thank you for your questions. I will start with the classes. So it's really astonishing that 20 classes should be enough. However, it's not to, the goal is not to understand the world precisely, but to have the minimum knowledge which helps to be successful in that very specific domain. And so the car does not have to recognize individual animals or so, but moving obstacles and not humans. So this is sufficient, be it a kangaroo, be it a wild boar or a deer or so. It's something which, where an accident should be avoided. However, it's not a human. So this is sufficient for that. So if we have more, if new technology or new items will arrive like drones or so, perhaps we need at some point 21 categories because this doesn't fit to an existing one. But this turned out to be the 20 categories which are sufficient for doing that precise job. In other realms of AI, care, robots also, then we have different classes, of course. This is just entirely for the automated driving. And regarding your question, absolutely correct that the behavior of pedestrians differs with time, and in different world regions, people have completely different behavior schemes. And this is why the whole industry will shift. So gone are the days where technology was developed, put in a car, and it rested there for 20 years safely and could work. AI is more dynamic, since it has to deal with a dynamic surrounding. So the systems have to be retrained over time, and so this will change the behavior and the business schemes between supplier and manufacturer as well. Plus, in different locations, we need specific training situations, and so this could be, for instance, if you cross the channel and have now traffic on the other side of the road, the scheme has to be adapted completely. So there might be even location-specific packages. This is one of the engineering challenges which come with AI, but you're absolutely right.
Jill and then Armin.
I completely agree that if we want to have safe systems, we need to have simpler systems. But there is a lot of room for simplification, which is to modify not the vehicle itself, but the environment of the vehicle. And the way our roads are built, they are built to work with the cars we have now, and not with the cars we'll have tomorrow, and there must be a co-evolution of the car and of the urban environment. For instance, the example you gave of recognizing a stop sign is nonsense, because the stop sign has been made to be recognized by a human. Why should a machine recognize this stop sign? We should change what a stop sign is so that the machine can recognize it. So there are many options. The stop sign can be a signal, or it can be a point on the map. We don't need to see the stop sign if it's on the map already. And it is the same for recognizing other cars. In airspace, the pilots do not see the other aircraft. They just broadcast their positions to the other aircraft, and this is how the air traffic control is organized. So can you say a few words about the evolution of the city in which the cars evolve?
Armin?
Well, I just want to add another question. Thank you for the great talk. So your logical chain goes from trust, which of course is a lot to ask, to plausibility, to consistency checking. And of course, if you, right there, consistency checking leads you into undecidable problems algorithmically. So it's a heavy problem. My question is, your major concern with, I prefer to speak of AI safety. Your major concern with AI safety, is it really cybersecurity issues of data getting corrupted? That's an issue of cybersecurity. Or do you also see intrinsic dangers in applying goal-directed AI, where the AI, in the way of optimizing their goal, may be in the danger of corrupting the reward system? That may also be a question.
Absolutely.
Go ahead.
Okay, so let me first tackle the first question. So we think that the environment is shared between machines and humans. So you will still need the road signs, because there are not only automated cars, but there are cars which are, for a long time, there will be cars which are not automated. And so it will be a mixed traffic. You will have pedestrians, cyclists, and so on. So you could, of course, support by infrastructure cars in the navigation. So this is something which we can do as well, and some countries invest heavily in that. China, for instance. The approach Europe will be taking is not yet defined. However, there is surely there's a variety of things we could do. So having not only intelligent cars, more or less intelligent cars, but aided by infrastructure. The point I was trying to make is simplicity is good, but making systems simpler is difficult. So dealing better with complexity might do the job as well, and here AI could help. To your question regarding cybersecurity and the risks of AI, it's an intermixture. I think we have to break out the existing silos and take a more holistic approach, because AI comes up with specific risks. You're absolutely right. And however, if we try to solve those risks and not deal at the same time with the external risks, which we put under the umbrella of cybersecurity, then the trustworthiness is still at stake, because the consumer, the user, and the everyday person which interacts with the system doesn't care whether trust was broken to an inherent flaw of the AI or by the evil work of an adversarial attacker. So we have to take stewardship or responsibility for what we do here and provide a holistic approach of safety. And we have to care for all those problems.
I've seen a few more who would like to speak. I ask you to come back in the cross-cutting discussion. I've seen Stefano and Marcus and you. Let's move on at this stage, and then the three of you take the floor at the beginning of the cross-cutting discussion. Thank you very much, Christoph. Your talk has added a lot of value to our workshop.